Hello everyone, thank you for coming. My name is Yash Mankad and today we are going to talk about testing in QEMU and libvirt beyond make and make check. So before we get started, a little bit about me. I work in the virtualization group at Red Hat, and our team is responsible for the virt CI test services. So we are responsible for setting up the CI environment for the virtualization components used within Red Hat, and for the last 6 months I've been looking particularly into setting the same up for upstream, and this talk is basically the result of that. So the agenda for the talk, I'm going to try and answer 4 questions today: what, why, how and where. I'm going to start with what is the state of testing in QEMU and libvirt. So what is the present state of CI, if there is any? What kind of tests do we run? Where do they run? Then I'm going to talk about why I think we should change, what is lacking in the state, so we should change. Then how will it work, the new CI or the new implementation, and where will it run? The last question is more of an open question because I don't have the right answer for it, but as we get to it, I think things will get more interesting. So let's get started. So the current state of virtualization testing, I'll start with QEMU, is that there are tests included in the QEMU source tree. They are basically unit tests. The CI environments, the current automated CI environments, they build QEMU from source using make, and then they run make check. In the source tree, there are also subsystem tests such as IO test, Coverity, TCG, Q-test framework, and other code analysis tests, but they're not part of the CI. They are run by developers who work on those subsystems. For libvirt, the test suite is present again in the source code, and it runs unit test. The current CI environment, it uses the autogen sh script to build libvirt, and then it runs make, and the CI environment runs a make check. Now libvirt's make check is not like QEMU's make check. It checks whether the XML that is generated by libvirt doesn't break QEMU. Like, it works with QEMU. That's what it runs. Now, over the last few weeks, my discussions with maintainers, with developers, and the community in general, I've spoken about the test, and the 2 words that come up the most often is that why they run these tests is because they're reliable and they're sufficient. We don't need the field to run more tests because, make check is reliable. If I write a patch and I run make check on my local machine and it passes, I am fairly confident that it won't break the existing CI upstream. A little bit more about the state of QEMU testing upstream. There are 3 CI environments, and the most popular is probably patchew, that runs for every patch sent to QEMU devel. It runs a Docker environment for Ubuntu, MinGW, and CentOS. It runs check patch, it runs make check, and this is a pre-merge. So it runs for every patch before merge. The other 2 are Travis CI and Shippable. They run the following environments, as you can see: Ubuntu and the Debian, the AMD64 version of Debian and Ubuntu. Both of them run make. They don't run any functional tests. They run make check, and they are post-merge. So once a patch is once a pull request is merged, then they basically make sure that you can still build QEMU. For libvirt, there's Travis CI, and there is a separate Jenkins instance on ci.centos.org. They both run VMs. The Travis one is a Docker container running Ubuntu. It runs make syntax check, make install, and make dist. It's post merge, and the Jenkins instance has a lot more distros that it tests. It has Debian, Fedora, Rawhide, FreeBSD, and CentOS. It runs make and make install, and it's post merge. I think Peter Krempa mentioned this in his libvirt status report in the morning that libvirt currently lacks a per patch testing or a pre-merge CI environment, but both of these have come up in the last year, and I think they're doing a pretty good job. So why should we change? What are we missing? So all the environments that are running right now or that I spoke about, they are all virtual environments. They're either Docker containers or they are VMs that are all running on x86. So we do not have a testing environment that runs on bare metal nodes. Neither do we have a testing environment that is running on ARM, Power, S390, except for, well, Linaro's Lava that is running ER64, but still no functional test. So we just run make check, and we run it on a VM that is running on an x86 system. The other issue is there is no integrated test framework for either QEMU or libvirt. The previous talk mentioned Avocado and Avocado BT. Kleberosa's talk mentioned Avocado and Avocado BT, and I would like to talk a bit about this because we use Avocado a lot internally in our CI environments. It has its pros. It can run on both bare metal and virtual environments. It has a lot of functional and regression tests. But over the last couple of months, I've found out that it's not the ideal solution for running in upstream because it pulls in a lot of dependencies, especially Avocado BT. It requires packages from repos that don't come with the distro by itself. Avocado BT is not packaged for all the distros. And if you can see the amount of tests in the pick the test part, there are more than 12,000 tests for libvirt and over 3,000 tests for QEMU, so which run a lot of combinatorial testing for virsh, which is not really functional test. When talking to libvirt developers, I recently learned that combinatorial virsh testing cannot be defined as functional testing. It is at best acceptance testing, and that is not enough. So how will it work? Here is where it gets really interesting. I have a simple two-step process for how it will work, and it's something like this. Step 1 is you draw the circles, and then step 2 you kind of complete it. So today I'm going to talk about step 1, and then step 2 will be somewhere down the line. So I'll try my best. So for QEMU, there is already an effort underway to add functional test as part of the developer workflow. If you were present in the room before my talk, you must have heard Kleber speak about this. If you haven't, I highly recommend Kleberosa's talk on the current state of functional testing for QEMU using Avocado. So if I were to summarize it, what the effort underway is basically the tests are present in the QEMU source tree, and the developer has access to a predefined VM that you can launch. You can add arguments, and you can run QMP commands with. Now, this will encourage developers to write more functional tests as features are being added. And my suggestion, or our suggestion, is to run this with patchew. As I think it was Connie who mentioned it in the moderator Q&A yesterday, patchew is respected by the maintainers and developers for the upstream QEMU community, and we feel that patchew is the right way to get functional testing into the developer workflow by making it part of patchew's workflow. So every patch sent to the QEMU devel mailing list will also have the acceptance test added by the developers being run on them. For libvirt, it is a little more in the air right now. So One of the test frameworks that I would like to talk about is libvirt TCK. Also, you see the question mark next to it because I actually added that last night based on feedback I've gotten over the last couple of days. Libvirt TCK is a test suite that's available in the Perl sysvirt TCK package. It has functional and integration tests for libvirt drivers, and it has a bunch of tests for domain, storage, network filter, etc. It is packaged for Fedora, but it is written in Perl. And based on the feedback that I've gotten from the libvirt community, they don't intend to contribute to the libvirt TCK tests in Perl. So one of the options may be rewriting it in Python, but that is a lot of effort. Also, libvirt TCK has a hard requirement of libvirt 4.4, so it doesn't work in Fedora 28. But if you try Rawhide or a 29 beta, it does work. It's the package is available in the Fedora updates repo, and I'm not sure if it's packaged for other distros, but this is one of the options that I looked into. Another thing I would like to discuss is the possibility of Avocado libvirt, similar to an Avocado QEMU, where functional tests are added into the libvirt source tree, and developers can add tests based on the features that they are writing. Thus having more control over the kind of tests running with like a make check or running as part of the build process and developer workflow. Where will it run? This is more of an open-ended question right now. So before I get into what I recommend, I would like to talk about the effort that is already in place. So I found out just today morning that both SUSE and IBM had donated, or well, they had given they gave some hardware for patchew to run its tests on. So patchew could not only run on the x86 systems that it has, but 2 PPC64 nodes and an S390 node, but they went down because they were out of space or there was some networking issue and they never came back up. So what seems to be the problem when it comes to this question is that it's not the hardware resource that's an issue. Vendors and companies are willing to donate systems and give more hardware. It's actually a people issue, and I'll get to the bigger point in the summary slide. But the issue with having a functional CI is people or the community actually having to donate their time to make it functional. The continuous part of continuous integration is very important. Just donating systems and then having them run on its own, it's not going to happen. We need people who have to be admins for these systems and look after their upkeep and make sure that they keep on running the tests. So my suggestion, and based on my experience running virtualization tests over the last year, I strongly recommend running virtualization tests on bare metal systems. Yes, nested virtualization is supported, but you will only be able to run you will only be able to run integration tests in a true bare metal environment. So my recommendation is the CentOS CI infrastructure. They have 38 x86-64 bare metal nodes, and they have 64 AR64 and PPC64 LE virtual machines. They can be requested using an open source provisioner called Duffy, and they are also working on adding AR64 hardware to their current environment. Now this takes off the burden of one particular person being the admin of an infrastructure, because the CentOS I think is the word SIG group that will take care of this, like the CI SIG and the word SIG group. You can provision a bare metal Fedora or a CentOS node or you can create a Debian VM, and we can run the test in this environment. The second option that I want to present is getting on board with Fedora CI Initiative. This is part of the always ready operating system. So tests will be defined in a standard test interface, which is basically a YAML file that will be stored on the dist-git tree of the package and run using Ansible for every new build. So whenever there is a build, the test from the test.yaml file defined in the test directory of the dist-git tree will be run against at least an x86 system, and they are planning to add multi-architecture support. But most importantly, what I would like to talk about is tying in the existing the functional test, the Avocado QEMU or libvirt TCK or Avocado libvirt or any other libvirt test with the current environments. What I have found out is we need to make functional tests part of the developer workflow in a way that they create a meaningful feedback loop for anyone who's trying to contribute patches to these communities. So, and it has to be simple. You cannot expect people to set up an environment or bootstrap or add a repo or add dependencies in order to run test. It has to be in the source tree, it has to be simple, and it has to be meaningful to the people actually contributing code. So one of the suggestions that came up from the QEMU CI BOF that was run yesterday was to actually have patchew run functional test and then be integrated with both Travis and shippable in a way that it becomes kind of like the CI dashboard, like a one-stop shop where you can get information about your patch, who's reviewed it, what is the status of the test, and whether it has broken the Travis CI, or well, not broken, but whether the Travis CI or the shippable builds have passed. And we actually already spoke to FAM, and it is possible to do this. So this makes a lot of sense for us to do, is to have patchew be that centralized CI environment where developers can have an overview of their patch, reviewed, whether it is reviewed, whether it is being tested, or whether it broke the build. Maintainers can also use patchew to run their own scripts. So we know that Peter and Paolo have a set of scripts that they run before every pull request. It would make sense for patchew to let them run their scripts as part of this workflow. So that's one of the suggestions that I had. So to summarize, currently QEMU and libvirt CI, they run a lot of make and make check, which are basically unit and acceptance test. My recommendation is to start adding more functional tests for QEMU and libvirt. The emphasis on adding and not on running, because we need to add them into the source tree so that we can make it easier to run them. When I actually submitted the abstract for this talk, the name of the talk was Beyond Make and Make Check, because I wanted to look what else is out there, what are the options. Can I run something apart from Make and Make Check that will let me run functional tests as part of for QEMU and libvirt? But as I've been learning over the last couple of weeks, that wouldn't be a solution. The solution would be to integrate functional tests into Make and Make Check or Make Check, so that they are part of the developer workflow. And yeah, so basically let's start adding more tests. Let's start contributing to the Avocado QEMU project. Let's discuss the possibility of an Avocado libvirt project, so that we have functional tests as part of the workflow, and then we can work towards a functional CI for virtualization packages. Thank you. questions?
So from my experience with functional tests, the best way to get them is to when you're working on a bug, you have like an image which reproduces the bug. So functional testing, in my opinion, is just a bunch of bugs that you fixed and the images that helped you reproduce them, right? The setup. Is there an easy way to upload your image or something like that? Or this flow should be very easy, right? Should be made very easy, like uploading your image,
yes,
creating your setup, and this is in effect the functional test. So is there a way to do it right now, or what do you think is missing for us to be able to do it?
I think Kleber wants to answer it. Sorry.
So I'll just try to help what I know. So we had a similar request before, and we host avocadoproject.org. We have a reasonable amount of space. And eventually what we would like to do is set it up as like people could could post, upload their images and reference them in the test in the same way that we're using the cloud images. So we haven't done that before yet because there really hasn't been anyone pushing it, but would like to make that available.
Right. Sam.
Yeah, I can add something. So for smaller images, we do have some kind of disk images that are compressible, and they are directly committed into the testing directory. For example, we have I/O tests that they are with only headers and little data. And we also have this VM-based test that to support the BSD images as a build host for QEMU. So this test, before we don't have a good way to store them somewhere. So my experience was to just not upload to somewhere that everybody can download, and then commit the URI into your test code. Then it can somehow run. But in the future, maybe yes, we may have something better to store images.
Sorry, I'm going to keep talking about images. So be able to download images for distros is great, but one of the problems we have with QEMU is the range of architectures that we need to support. So it's great for all the mainline architectures that are supported by Fedora and Debian and whatever, and you can be fairly confident when you download a kernel from them that you're GPL compliant and you can get the source code for it. But then we've got all these other architectures that we'd like to be able to have test images for, and I think there's some that are linked on the wiki page, but really we have no idea of where they were built from, what the source code that they were built from, and we're sort of hesitant just to have a place where you can dump random images that you don't really know where they came from. So what we're trying to work towards is a solution where we've got a verified way of building an image that you can use to test, and then anyone can regenerate it and be confident that you've got something that's not just some random bytes.
So first, one clarification for the libvirt CI, the stuff that runs on Travis CI and the stuff that runs on the CentOS CI, it's identical. Like the only reason it's not exactly identical in range is because there is a limit to 5 jobs on Travis, so we don't have the same range, but we try to basically cover all of the same scenarios, kind of.
Okay.
The other thing that I wanted to say is that I would love to have more testing on more architectures and run some functional tests. The problem is mostly that if, for example, in the CI CentOS environment, as you were saying, we only have access to PP64 VMs. So how are we supposed to run functional tests on a range of on that architecture, on a range of distros, when that involves spawning guests on top of it, it becomes like super slow because then you end up using TCG.
Yeah.
So that's my main problem with that. Because otherwise, I'm totally on board with having more architectures, more distros. The more, the better.
Yeah. So this was brought up in the BOF yesterday. Is that where do we start? How do we run on architectures that for which bare metal systems are not widely available, and it comes down to vendors or companies who are willing to donate hardware towards a CI effort. So Red Hat is willing to start with having one server dedicated to CI. For example, let's run just upstream QEMU test or upstream libvirt test, and then if Linaro wants to donate an AR64 system, we can add it to the CI pool. It can be in their data center just running upstream test, but what we want is basically the same set of tests that the community accepts. So something like libvirt TCK, I know that's not ideal, but something like libvirt TCK or something like Avocado QEMU running on all architectures. So if your company or if you want a particular architecture supported, then you should be willing to put up the hardware for it. And again, as I said, hardware is not the issue. There were PPC64 systems donated, but then there was
Hardware is not the
only issue. That's true. Hardware is not the only issue, but the primary issue seems to be time and people. No one is willing to donate people for a dedicated CI job.
Okay, thank you. I think we need to move it outside. Okay.
Feel
Thank
free
you.
to email me or continue the discussion on QEMU Devel or libvirt list. Thank you.
Okay, thank you very much.